Okay, guys. So we are continuing. If you all remember, where we left off yesterday was we graphed this polynomial, we graphed this function, and what ended up happening is we knew that it was a fourth degree, meaning there's going to be 4 zeros. But when we graphed it, we just had one double root. What do I mean when I say there was one double root? What does that look like, a double root, Erin? Good. It hit the point and then it bounced back up. But when it's a double root, how many times does that count? Twice. So what ended up happening was we got a double root at x equals -1. But now that's going to count twice. So x equals -1, and then another time x equals -1. So this is the first root. So we'll call this root 1. This is our second root, root 2. But how many roots do we need altogether? 4 roots. So this is where our algebraic knowledge has to come in. This means because we didn't see it on the graph, our 2 remaining roots are imaginary. So we are going to use synthetic substitution on our original function to get it down to a degree of 2. Once it's down to a degree of 2, then we're going to use the quadratic formula to find our imaginary roots. Kim, was your hand up? Are you good? Okay. So let's do this. Right, so we're going to take x equals -1 and use that in our box. And then we're going to go back to our function. Is every exponent accounted for? Yes. So we're just going to write out our coefficients. So we are 1, 5, 15, 19, 8. So now we bring this down, and we're going to have 1 times -1 is -1. 5 plus a -1 is 4. 4 times -1 is -4. 15 minus 4 is 11. 11 times -1 is -11. 19 minus 11 is 8. 8 times -1 is -8, and we get 0. Should that last column be 0? No. Yeah, absolutely. Why should that last column be 0? There's no remainder because it is already a factor, right? It's already a factor. We already know that it's a factor. So since we know that it's a factor, if that last column wasn't 0, what would that tell you? You did something wrong, right? You did something wrong. So now this was originally a degree of 4. And now this would have to be a degree of 3. What do I need it down to? A degree of 2. But because it's a double root, I'm going to have to use -1 again. If it weren't a double root, I would use whatever other root I saw. So now I'm going to use -1 again. And we are 1, 4, 11, 8. And you use your new coefficients. Use your new ones. Bring down that 1. 1 times -1 is -1. 4 plus a -1 is 3. 3 times -1 is -3. 11 minus 3 is 8. 8 times -1 is a -8. 8 minus 8 is 0.
We don't do the 0 at the end.
I'm sorry?
Do we count the 0?
Do we count the 0?
Like up there, there's a 0 after the 8.
Nope. We don't use that 0. All right, so now I started off at a degree of 4. The first synthetic brought us to a degree of 3. The second synthetic brought us to a degree of
4.
2. All right, so what is it? This is now going to be x squared plus 3x plus 8. And we need to find the zeros. So we're going to set it equal to 0. And we're going to use quadratic formula.
not account for the 0.
No, the 0 there, that whole column canceled, so there's nothing there. There's no point in writing plus 0, right? What's plus 0? Saying add nothing. Who remembers the quadratic? X is equal to, Nico?
Negative b plus or minus square root a squared.
B squared.
B squared minus 4ac divided by 2a.
All over 2a, you got it. All right, you all tell me, based on my quadratic, what's my a? Based on this, x squared plus 3x plus 8. What's my a? 1. You got it, right? There's an invisible 1 here. What's my b? 3. What's my c? 8. So now we're going to plug into our formula. X is equal to negative b, so that's a negative 3 plus or minus the root of 3 squared minus 4 times 1 times 8 all over 2 times 1. Okay, now we simplify. X is equal to negative 3 plus or minus 9 minus 32 all over 2. I just multiplied underneath my radical. So now we're going to have x is equal to negative 3 plus or minus the root of 9 minus 32 is a negative 23. You are not allowed to have a negative underneath the radical. So how do we fix this? You got it. Whenever you have a negative underneath the radical, you pull out an I. So this is going to be negative 3 plus or minus I root 23 all over 2. And that is our root. How many roots are here written down? 2. Why 2 and not 1? Aaron? Good. Because it's plus or minus, this counts as 2 different ones. Nico?
When I do these type of problems, I get those type of answers. You know, how you have like the x equals, then it's like the fraction sign.
Mm-hmm.
Sometimes I cross it over into the x. Would you count that as wrong? Because I got like
Yes.
4 columns on the quiz like last year wrong, even though I got like the right answer. And
I would count it wrong.
Crazy.
Sorry, because it's not the same. You're changing the value. Okay. So now I asked for roots and factors. So our roots are going to be x equals negative 1. But what do I want you to write since it counted twice? I want you to write dr to let me know that counts twice. That's your double root. And then the other roots is going to, the 2 other roots will be x equals negative 3 plus or minus I root 23 all over 2. All right, now your factors. So for your factors, what you're going to do is you're just going to set it back equal to 0. So for the first root, you had x equals negative 1. But now to set it back equal to 0, what should I do? Add 1 to both sides. So this is going to be x plus 1. But how many times did this negative 1 count? Twice, right? So what we're going to do, this is x plus 1 squared. Because that negative 1 counted as a double root. It counted twice. And for the just to make it easier on us, for this crazy I one, all you're going to do is just move it over to the other side. So do you see how this is a -3? What you're going to do is just make it a plus. So x equals, oh, sorry, x plus 3 plus or minus I root 23 all over 2.
A lot of steps inside of them.
So our factors are x plus 1 squared So on the quiz on Friday, I'm going to have 2 questions that just say find the zeros and 2 questions that say find the factors. But the one that zeros are roots, they're the same thing. You need to know they're the same thing because I'll interchange those words. When I say find the factors, it won't be anything so crazy. Yeah.
Throw in an extra credit problem.
Can I throw in an extra credit problem?
Heck yeah.
Sure. All right. Let's do another one. So I want us again to, what number is this? What number was this? This was just number 2, right? We had only done 1. So this is number 3. So again, I want us to find factors and zeros. So 6x to the 4th plus x to the 3rd minus 31x squared minus 5x plus 5 equals 0. Okay, so try to remember, what's the first thing we're going to do here? Right? Good, P over Q. We're going to find our possible rational roots. So remember, our constant is P, our leading coefficient is Q. So I need factors of P, so we're going to do factors of 5 plus minus 1 plus minus 5 over factors of our leading coefficient. So plus minus 1 plus minus 6 plus minus 2 plus minus 3. And now we pair every numerator with every denominator. So our possible rational roots are going to be, I'll just do it over here, P over Q, will be plus minus 1, plus minus a half, plus minus a third, plus minus 1/6. Now we move on to 5. So we're plus minus 5, plus minus 5 halves, plus minus 5 thirds, plus minus 5/6. So what we want to do is we want to find 2 of these that work. Once I find 2 of them that works, that means I can use synthetic substitution how many times? Twice to find the remaining ones. So where do I go now? Into my calculator. Let's just write these possible rational roots for ourselves. Okay. Go to our calculator. So we're entering in our function. All right, I'm just double checking this. We ready? Let's hit our graph. Oop. Oh wait, I had it already zoomed in. Does anybody remember how to get it to our standard graph if I already have it zoomed in?
Zoom standard enter.
Good. Zoom and then zoom standard and enter.
You did trig.
Did I do trig?
Yeah.
Okay. I don't want to do trig. There we go. There we go. Okay, now this looks definitely like we have 4 roots here, right? But I will tell you, imaginary roots won't show up, but irrational roots will show up. And what do I mean when I say an irrational root? So for example, the square root of 2 is an irrational number. What does that mean? It means that decimal keeps going on and on and on forever, but not in any repeating way. So irrational roots will show up, imaginary will not. All we have is the list of rational ones, meaning if it's the root of 2, it's not going to come up in this list, which means I would have to use the synthetic to get this. So let's see if we can find anything. So, yes. Yeah, the X.
Is that a window or?
No, so you mean to change it to the table. So you're going to go to second window, press second window, and then your independent should say ask.
Okay.
You hit enter and then you hit graph to get out of there. Okay, so I'm going to look over here. I'm going to put my cursor over here. So over here, it says it's negative 0.45. Isn't that pretty close to negative a half? Right? Is negative a half in our list? Yeah. Then I'm going to go over here because it looks like it's a pretty equal. And then it says positive 0.45. Isn't that really close to a half? And I have a positive a half. So that's where I'm going to start. So I'm going to go to second table. And remember, when you do your negative, don't do a minus. What should we do? The negative under the 3. So we're going to do negative 1 division sign 2. And does it yield us a 0? Yeah. So we definitely know 1 root is negative a half. We need another root. What's that?
From the graph, how did you get to that?
Okay, you're going to press second graph. The second button and then graph button. You got it?
Yeah, I got negative 5.
What
When I
happened?
put in negative 0.5, I got negative 5 as the y.
Uh-oh. What happened?
Yeah, I didn't get it either, but I'm thinking if I put it in wrong. I think I put it in
6x to the 4th plus x to the 3rd minus 30. Nope, you did plus 5x instead of minus 5x.
These are a bunch of rounding because when I go to like I just did more. I know it's
Mostly
like,
right.
like negative 4.7 or like negative 4.2.
Yeah, that's not completely accurate because it's just the cursor.
Okay.
So that's why we do the second table and we enter in our numbers to make sure it yields a 0.
So do you even have to look at this? Why can't you just plug it in?
So, because if you sat there plugging in all those positive and negatives, it would take you forever. So that gives us a bullet point to what's close to it. So when it says 0.47,
You gotta make an educated guess on it.
it helps you make an educated guess for which ones to try out.
Alright, that makes sense.
Every time I try to put something down and after it just says that there's a window range. Yeah, right. Error.
You did Zoom standard, you might have.
Yeah, it worked.
All right, I'm going to reset yours.
Is your why?
Think the IT.
No.
Yeah, well, no.
Okay. Now try entering it again. Hopefully it will work.
Negative. No negative.
Is that what?
Yes.
What's the whole thing where you have to try to find the
There you
comment? Like,
go.
what degrees does it go up to? Like what degree?
What degree?
Yeah, degree. Like it goes to like the second degree or the fourth degree.
That tells you how many zeros you're going to have. How many roots or
Like, how do you
zeros.
figure that out.
It's the highest exponent in the polynomial. Okay, so we got root 1. Did everybody get in their calculator that negative a half yields a 0? We got that now? We're good? Okay, so now let's go back and let's try 0.5 this time. So we're going to do 1 divided by 2. Ooh, that does not give us, did I do it wrong?
No, you're right. It didn't.
It did not give us. Okay, so we got to go somewhere else. So the half did not work. Let's go back then to our graph and see. Oh, now it looks like it's 0.3, right? When I move my cursor again. So 0.3, what's close to 0.3? Isn't that 1/3? So now we're going to try 1/3. Second table. So now we're going to do 1 divided by 3. And there we go. The 1/3 actually gives us the 0. So root 2 is a positive 1/3. I am? Your what? Your table's blank? Yeah, your table should be blank. Because you have to enter in the numbers. Mine is just from all the times I've done this. Oh, okay. So what you want to do, you have to do the table set. Second table set. Oh no, you have auto ask. There you go. And now you're going to do 1 divided by 3. Yeah. Now that we have 2 roots, can I now go back to my paper and do the rest of the work? Absolutely. So now let's go back to our paper. And we know root 1 will be -1/2, and root 2 will be 1/3. What's up, Nico?
I tried like looking up for another root like all the way to the left, like the first point we saw, and I got like -2.
And it doesn't work because those end up being radicals. So nothing, if you tried putting in every single one of these, it won't work out. And that's why I said once you find 2 that work, just do it on paper because you'll spend a lot of time just trying to enter all of these in. All right, Nico said he tried, let's go back just to show you. Nico said he tried to find these 2. And what ended up happening is none of them really worked. None of these worked for these two. And that's because they end up being radicals. And these are rational numbers, not radicals. So that's why I said once you find two roots that you know work, don't waste any more time with the list because it just takes too long. Just go back and do your synthetic on your paper. Okay, so now how do we do this? I'm going to take my first root, which is -1/2, put it in the box, and now we're going to take all of our coefficients, 6, 1, -31, -5, and 5. We're going to bring that 6 down. What's 6? What's half of 6? 3, but it's a -1/2, right? So wouldn't that be -3? And then I have 1 minus 3, which is a -2. And then what's half of 2? Half of 2 is 1, but because they're both negative, it becomes a positive.
Why are we dividing by negative? How do you get that?
How did I get the -1/2?
Yeah.
That was what we just did on the calculator. Wasn't the -1/2 one of our zeros?
Yeah, but do you do it for both? So -1/2 and then you do it again for the third?
Yeah, so we're going to first do the -1/2, and we're going to get this degree of 4 down to a degree of 3. Then we're going to use the 1/3. So then we have -1/2 times 2 is a positive 1. -31 plus a positive 1 is a -30. What's half of 30? 15. They're both negative, so that makes a positive. -5 plus 15 is a positive 10. Half of 10 is 5, but isn't it a positive times a negative, which gives us a negative? Should that column be 0? Yes. Okay, now what do I do? So now I had originally a degree of 4. I brought it down to a degree of 3. What should I do now? Ian? Use the 1/3. Now, when I use the 1/3, which numbers should I use? Should I use my original numbers or these numbers? The second numbers, the new numbers. So we're going to have 6, -2, -30, and 10. Yes.
How do you know what order to go in? Like, say you use 1/3 first. And then
You could have, no problem.
No problem.
Yep, you're still going to work out the same. All right, we're going to bring the 6 down. And you guys all agree multiplying by 1/3 is the same as dividing by 3? All right, so we're going to say 6 divided by 3 is 2. -2 plus a positive 2 is 0. 0 times 1/3 is 0. -30 plus 0 is a -30. -30 divided by 3 is a -10. 10 plus -10 is 0. So now we're down to a degree of 2. So now we have to write it out as a polynomial. So this is going to be 6x squared minus 30 equals 0. We're going to now use, or no, we could actually just solve. Now we're going to solve. Well, it's 0x, right? So this was really 6x squared plus 0x minus 30. So I just didn't write the 0. I don't need to use the quadratic here because I can just solve. So this is going to be 6x squared equals 30. Then what should I do? Divide by 6. So then I'm going to have x squared is equal to 5. Now be very careful. The minute you take the square root, what do I have to write in front? Plus or minus. How many roots does this count as? 2. 1 positive, 1 negative. So now we write out our roots. So roots will be x equals -1/2, x equals 1/3, x equals plus or minus √5. Or if you wanted to write this out twice, you can. X equals positive √5, x equals negative √5. Doesn't matter.
Yeah, so the plus or minus just counts too. It's like however you want to get them.
Yep.
Okay.
Right, but I didn't just ask for roots. What else did I ask for?
Zeros.
Roots are zeros. Guys, roots and zeros are the same. And you're going to see me always interchanging those words. So I asked for roots, but what else? Factors. Now, when you find the factors, please don't mess this up. I don't want you just to add the half over. Remember the two-step process? When we're dealing with a fraction, what should I do first? Multiply by 2. So x is equal to negative 1 over 2. I'm going to first multiply by 2. So then we're going to have 2x equals negative 1. Then what should I do? Add the 1, negative 1. So I'm going to add that 1 over. So our factor will be 2x plus 1. That's one factor. So then we have x equals 1/3. How do I change this back into a factor? Same thing. So first step, multiply by 3. So now we're going to have 3x equals 1. Then what should I do? Subtract that 1. So we're going to have 3x minus 1 is our second factor. Then we have x equals root 5. All you do here is subtract that root 5. So we're going to have x minus root 5. And the last one, x equals negative root 5. This time you add that root 5 over, and you're going to get x plus root 5. Now let's say you didn't want to do all that work. If you would have ended up with your root as x equals plus or minus root 5, you could have just written x plus or minus root 5 as your factor. Nico, was that your question?
Yeah.
I knew it. Okay, I'm going to give you one to try on your own, and then we will be done. Yes.
If you take points off to the final root, you write plus or minus. You get like separate.
Nope, you could write plus or minus. That's perfect.
This was just in the first space.
All right, we ready? Trying to find one with not too much P or Q.
Give us one. We got to use quadratic formula.
The quadratic.
Yes, you can.
Okay. I'll give you one with the
Do you have
quadratic.
no homework to study?
No, you have homework today. You have to practice this. It's the only way you'll memorize. All right, this time I'm just asking you to find the roots. No factors. Find the roots. No, quadratic formula gives you the roots. So we're going to have P of x is equal to x to the 4th minus 5x cubed plus 4x squared plus 3x plus 9. So remember, a quiz just on this on Friday. Just on this on Friday.
We only put 3 ones.
Say it one more
We
time.
only put 3 ones for factors.
For the fact, yes, only put 3 ones. Oh, no. Oh, I see, because it's 3 times 3. Is that what you mean? Yeah, you only put it once. Sorry. You're good. I thought you meant something different. double root. It looks like, right? But make sure it's a double root. How do you make sure it's a double root? No. Oh yeah, not second, but just clear that draft. Make sure your cursor's in that area. Put your cursor over there, and then you just press zoom, not second, and then zoom in. Okay, before you assume it's a double root, just zoom in and make sure it is, and there you go. That's proof that it's a double root. Now you go back to zoom standard. Yeah, so now just make sure of it. Perfect. Need any help, or you're just waiting? Okay. Anybody need help? Okay, give me a second. It really looks like there's a double root there, right? So what you want to do is you want to make sure it's a double root, so you want to bring your cursor over to it. And sometimes it looks like a double root, but it's not really a double root. So you bring your cursor all the way there, and then you want to zoom in. So you zoom in, and then
Miss your breath.
okay, so a double root. Yeah. How do I know it's a double root? It's an angle root. You just hit it in that way. So now just do your over to it. Yeah, perfect. So really the one that's here, right? So just see what is this?
Maybe you just have to
Point. Yeah, great. So now how do we make sure it's 30?
I mean, it should be a difference. Right? I'm sure it does.
There you go. And now
Yeah, but
that
they
is
should look
how
back.
many times?
If you're doing that
Why?
one,
It's because it's a double root. So
I
you're
can
going to
do-
do, so you're going to write down root 1 is
I think
3,
we do straight up.
root 2 is 3.
because mine just does not look like that.
Yeah, because it's a double root. And now how many roots do we go together? So we go to the highest exponent in your original function.
Oh.
4. That's
Okay, now we both
Wait, what did we just do?
That's why knowing
I
this
put the
comes
zoom
from
standard.
Me too, I just put it as a
Okay, now it's
So you
just
have 2 out of both ones.
So it's
So now what we're going to
so
do
only
is the synthetic substitution double down to a degree of 2. So then we can use quadratic as well.
3.
Yeah.
Are you okay?
One.
Oh yeah, the
So
no,
wait,
it
the
was,
only one is 3?
I think it was 3 and I did 3. Yeah, it was 3. I typed them all in.
3. Negative 3. Also minus 3.
It's
It's just 3. Did it double that means?
yeah, I mean it just touches it. If it touches the line, then yeah.
Right? So now you're down to a degree of 3. Going to do it again. So you go to your second root, which is also 3.
Okay.
Yeah.
Wait.
Okay.
So it's a double one?
Mm-hmm.
So now it's down to a degree of 2. So now
What
you're
is
going
it?
to have
D.
to ready.
What?
These are the substitutions.
D.
Zero.
Yeah, it's a one.
One, one, zero.
These are the numbers that go in front of it, right? So because
And
it's
I
down
think
to a
we
degree of 2, you're going to do 1x squared.
Oh,
Do we do the thing now? Or
synthetic.
yeah.
So yeah, you
You
put
put
3 in the
box.
little boxy thing.
And then 1 minus 5.
It's yeah,
Now you're
it's
gonna use the
1
quadratic.
negative 5, 4, 3.
We're gonna do the whole quadratic thing.
So
If it's final, you can just 2 times, you can just solve by square root thing. If it's 3, you'll use the quadratic. Sure, ready? I'll tell it to you. So you want to memorize this. X
negative 8 times 3.
Negative 8
What did you get? 8.
plus or
I got it. I think I did it right. So that's fair.
minus 4
Oh, this?
AC all over
Oh yeah.
What did you get? We're doing the same thing though.
But if the 1 is supposed to come up.
Are we ready to go over this?
3 times 1
Like-
is 3.
You did perfect. Now you gotta
You
use
bring
the
the 1
quadratic.
down and then 3 times 1.
Yeah.
Oh, okay. Okay. My bad. 2.
It goes along.
Mhm.
6. And then you have to do it again.
Yeah, put 3 again, right?
Yeah.
Yeah, you do 3 again.
Yeah.
Not plus minus. This should be a minus. B squared minus 4AC. Yeah, just extend that radical. Down. Y2. Negative 1.
This one?
No, this is a negative 1. Negative 1 plus or minus. Oh, nope. You got it. You have to simplify under the radical now.
They're all just 1.
Yeah, but we still have to do the whole thing with the equation,
Negative 3.
right?
Don't break the equation.
Yeah, we could do.
We're finding the roots.
What do I have to do?
And that's your third and fourth root. What's your first root? What's your first
No,
and
so the
second?
roots, it's just 3. DR.
Twice, right?
And it's what? 1
That would be your factor. But when I just asked for
squared
roots,
plus
you're going to write,
x plus
so
1.
this is, I said find just the roots, not the factors. So you're going to say the roots. X equals
We
3.
use the quadratic.
And then you can write X equals 3 again, or you
That's the
can
whole
write
point of this,
DR,
right?
double root,
Well, we didn't do it in the
Yeah.
last problem.
and
That
then,
just do X squared? No.
no.
We did it because it was you
So
only
then-
had 2
and then
numbers
X
in the end. It
equals
was 6 and negative
1 plus or
30.
minus I root
So that you just could solve for. But when
Those
it's
are your
Oh, I like
numbers.
the big equation.
Good job. All right, guys, what should you have gotten? Are we ready? You should have gotten, for our roots, X equals 3, and then you had to write DR double root, or if you wrote X equals 3 again, I would take it. But you had to show that this counted twice. So either you put DR for double root, or you write it twice. I don't care which one. And then you're going to get your X equals negative 1 plus or minus I root 3 all over 2 using the quadratic. How many people got this? Yay. All right.